All right, so for question 3, we've got the perimeter of a rectangle is 56 centimeters. If the length of the rectangle is 3 times its breadth, determines dimensions. So first what you do is draw a rectangle. And then you have to let one of the breadths here be x here, which means that the length is 3 times of that, which is 3x. Okay? Then because this is a rectangle, opposite edges are the same in distance or length. So now you have to use this part of the sentence, which says the perimeter of the rectangle is 56 centimeters. We can add all that together so that we get 3x plus 3x plus x equals to 56. Okay, so what that means is now 6x plus 2x gives you 8x equals 56, and so x would equal to 7. Okay, all right. Question 4. Tickets to a concert cost $5 for children and $14 for adults. Altogether, 650 people attended the concert and ticket sales totaled that much. Let A stand for the number of adults and C stand for the number of children. Explain why equations A plus C equals 650 and 14A plus 5C equals that. Okay, correctly matching information. So A plus C, where A stands for the number of adults and C stands for the number of children, if you add them together, that will just give you the total number of people being adults and children. Okay, so I'm just going to say here, A plus C equals to 650 is the total number of people. Whereas 14A plus 5C equals to 5824, that represents the total cost because the 14 here represents the $14 for each ticket. Okay, so that's the adult ticket. Okay, and A here represents the number of adults. So if you wanted to find the total cost of all the adult tickets, it's the number of adults times the cost per adult ticket. And similarly, you have the cost per ticket for a child, which is $5 here, times the number of children, which is C. So that gives you in total the total sales, okay? Okay, so these are the total sales of the tickets. Right. Now in part B, they want you to solve the equation simultaneously to find the number of children that attended the concert. So if you have a look at these two equations, okay, we can call them equation 1 and 2. And what we can do is we can use elimination method. So I'll call this equation 1, this is equation 2. So get equation 1 times by 5 here. And so what that will give you is 5A plus 5C, and 650 times 5 will be 3,250. And what I've generated is now two equations, both with 5C here. Okay, so I can minus them because they're the same sign. All right, I'll call this equation 3. I'll get equation 2 minus equation 3. And that would mean I'll get this 14A here subtracted by 5A there. That's 9A. 5C minus 5C cancels, whereas 5824 minus 3250, that will be 2574. And then next what you do is divide by 9 to solve for A. So A would equal to 286. Okay, but the question says to find the number of children. I haven't found that yet. I need to put this back into the first equation to find the number of children. So I'll just say sub into 1 so that I get 286 plus C is 650. So 650 minus 286 will give you 364. Okay, so I get 364 children who attended the concert. Right, let's move on to question 5. Aaron is 3 times as old as Sujudi. The sum of the ages is 48. How old are Aaron and Sujudi? So I'll just let Aaron be A, okay? Oh, whoops, I have 3 A's there. Aaron equals A, and so Judy equals S, okay? So Aaron, A, is 3 times as old as Judy. So A equals to 3S, okay? Now the sum of their ages, which means Aaron, A, plus Judy, S, is going to become 48. Now, because I already have one equation where a letter is a subject, I'm going to directly substitute this into the other equation. So I'm going to sub 1 into 2, which means every single time I see A, replace that by 3S. So that 3S plus S equals 48. That means 4S equals 48, and S equals 12 once you divide by 4. So I found out Judy's age, that's okay. I need to find out what Aaron's age is. So let's put that back into the first equation. So I'll go sub into equation 1. So A equals to 3 times 12, which is 36 years old. Okay, so there you have it. You got those 2 ages, 12 years old and 36 years old. Right, question 6. The sum of the ages of Mrs. Bui and her daughter Haley is 70. The difference between the ages is 38 years. How old is Haley? So, let's say Mrs. Bui equals to B, okay? I'll just make a capital B this time. And then the daughter Haley equals to H. So what that means is the sum of their ages, when you add them together, gives you 70. Let's do B plus H to get 70, okay? The difference between their ages is 38 years. So just be very careful here, whether it's B minus H or H minus B. The daughter will be younger. So if you want to have the difference and of their ages and it's positive, you must get Mrs. Bui's age minus Haley's age. So you get B minus H, and that will be 38. Now, given that these letters have the same coefficients, okay, but H has a different sign, I will add them together so that the H's eliminate, and you have B plus B, which is 2B, whereas 70 plus 38 is simply 108. Dividing this by 2 gives you 54. Oops. Okay, so that 54 will be Mrs. Bui's age, but if you put that back into this equation, you can find out what Haley's age is. So 54 plus H, 70, which means H is going to become 16 as you move 54 over. Okay? All right, question 7. NASA bought 3 punnets of strawberries and 5 punnets of blueberries for $35.45. Sarah bought 7 punnets of strawberries and 2 punnets of blueberries for $34.48. What was the cost of each punnet of strawberries and blueberries? Okay. So we've actually been told how many punnets of strawberries there are, okay, in each case. So what we're missing here is the price of the strawberry, okay? So let the prices of strawberries, okay, equals S, and then the blueberries equals to B. So I've got 3S and 5B here. That is supposedly equal to 35.45. Whereas Sarah has 7 punnets of strawberries, so 7S plus 2B, and that's equal to 34.48. So there's my 2 equations. Now, what I'm going to do to them is I need to find out the lowest common multiple, maybe of the B's, which is 10, okay, between 5 and 2. So I need to multiply equation 1 by 2 to get 6S plus 10B. Now I need to double that, so 35.45 times 2 is 70.9, and that's now equation 3. Whereas, I'll just put this way, whereas for equation 2, I need to multiply this equation here by 5 to get that into a 10b. So I multiply that by 5. That'll be 35s plus 10b. And 34.48 times 5 will be 172.4. It's equation 4. Okay, so once I've done that, I'm ready to, I guess, eliminate the 10b's. What I'll do is I'll get equation 4 minus equation 3, just so that when you minus these two things here, you get a positive answer. So I'll get equation 4 minus equation 3, so that 35s minus 6s is 29s. The 10b's here cancel out, whereas these two numbers, 172.4 minus 70.9 is 101.5. Okay. So once you divide both sides by 29, you find s. And that will give you 3.5. Okay. So that's the price of a punnet of strawberries. Whereas for blueberries, you're just going to substitute it back in here. So I'll sub into equation 1, which means that I'll have 3 times $3.50 or 3.5 plus 5b equals 35.45. I can simplify this. Okay. I can move that number, 10.5, to the other side, so that gets minus into 35.45. So I'll get 5b equal to 24.95. And then finally, I divide by 5 to get b by itself. So b would equal to $4.99, and that's the price of a punnet of blueberries. Okay. Right. Question 8. Let's move on. So for question 8, James has $10 in 5-cent and 10-cent coins in his change jar and counts 157 coins in total. How many 10-cent and coins does he have? Okay, so the thing that's missing is how many of these 5-cent coins and 10-cent coins he has. What I'm going to do here is I will let x equals to number of 5-cent coins, whereas I'll let y equals to number of 10-cent coins. Okay? All right. Now there's two ways you can actually do this, either by keeping it in cents like this or using dollars. I would prefer if we actually used cents. Okay, so if we just start off with this thing here, that the fact that they counted 157 coins in total, that's the total number of 5-cent coins, x, and total number of 10-cent coins, which is y. So you're going to add those together, and that will give you 157 coins altogether. Okay, that's equation 1. Now, to get a value of $10, you got to add the values of all the 5-cent coins. Now, there's X number of them. So if I times X number of them times the value of each one, which is 5, then I'll have 5X. Okay, plus by 10 cents times by the number of those 10-cent coins, which is Y, and that will be 10Y. And that would equal to the value of all the coins, but in cents. So I've got $10, but $10 in cents is 1,000. And I'll call that equation 2. All right. So here we have a choice of using substitution and elimination. I use elimination. So I'm going to get equation 1 times 5 so that I can multiply that by 5 to match what this says. So I'll get 5x plus 5y equals to 785. And that will be equation 3. So equation 3 came from equation 1, which means these two are essentially the same thing. So these two are the ones you solve simultaneously. So the 5x's in these two equations, they can cancel out by subtracting, since they're the same sign. So I'm going to get equation 2 subtracted by equation 3. And that would allow the 5x's to cancel, whereas the 10y minus 5y gives you 5y. 1000 minus 785 is simply 215. Okay? Now dividing this by 5, 215 divided by 5 gives you 43. And remember, y represents the total number of 10-cent coins. And if you have a look at the question, they only want you to solve for y. So we've done it.